Hi, good morning. Good evening, everyone. Okay, so in the last session we talked about aggregator, right? Like how to perform the group by operations by using what aggregator transformation. Yeah. Venkat, you want to say something? Okay. So let me share my desk. Yeah. So, but what we did not discuss was as part of aggregator, in case if you get pre-sorted data as input to aggregator, how is it going to work? I didn't talk about it. Yeah. So plus we would also talk about the sorting algorithm because what kind of resources that would be expected by this particular what the sorted transformation. Yeah. So that's what we are going to do on today's session. Right? So let us see. So create a mapping. So as we all know that if we supply pre-sorted data as input to aggregator, then aggregator performs much better because part of the aggregator we are trying to do it outside. Yeah. Yeah. Starter, then followed by yeah. So that's it. Yeah. So let's go from the beginning and take any source. Yeah. Say okay. Yeah. Usually what we should do is key column, it's better to go with a numeric because numeric is faster than string data. Yeah. Um, in case if it is possible. Otherwise, we can also go with this and calculation part. Usually, we have got some max, min, some average, right? In such kind of operations, right? It is better to go with what a number, yeah, or integer or double, whatever. Right? Fine. Now, let us sort the data. So we apply sorting based on what key column, which is let's say C1 integer. Yeah. And then apply aggregation. As part of aggregation, right? We need to use the same sort key that we have used as part of sorted transformation. Here also it should be same group by right. Then aggregation could be anything. This doesn't matter. Yeah. Example max result. These operations are bit expensive operations. Yeah. Not from the usage, but real what resource consumption part. So let us apply this. Yeah. Second column we are using for calculation, that which is C2. Yeah. Now, if you go to response, right, you can just insert input because yesterday we got error message, right? sort keys are not ordered in ascending. So that we can avoid now because we have already sorted it. That's it. That's all about the sorter before aggregator. It's very easy. Configuration is easy, but internal algorithm is a bit complex. So max result in CDI dot AV, just cloud data integration. Right? Why we are putting CDI? Because I'll try to show with one example from artificial intelligence. Because even cloud, Informatica Cloud, they are using Claire, which is artificial intelligence architecture. Yeah? But mainly they have used it for conversion, which is unstructured structure. But we can also get it extended to others as well. Yeah? So now let's run it. Oh, mapping aggregator with the sorted data. Save. And run. Yeah. Yeah. After this, I'll show an example from artificial intelligence also. Then we'll get into unstructured to structured data conversion. Yeah. Okay. So let us refresh this. So we got 5 rows as part of the result. So this one, right? See, we got max, which is 118. If you go and look at here, so if you look at the value 1, right, which is part of first group, where we can see 118 is a maximum value. So we got it. Similarly for others. Anyway, this is straightforward. So here we are just trying to understand the sorter before aggregate, nothing else. Now, question: can we do it by using this particular AI? That's one of the tool, which is ChatGPT. Answer is yes. Here to get the job done, right? It's very, very easy. So let me write one prompt and see whether we could able to get the result of max or not. Yeah. So write a Python code, yeah, to calculate max, yeah, max aggregation with C1 as group by, yeah, group by column, yeah, and C2 for calculation, yeah, from a file which is C:/source /sec_1.txt with a comma delimiter. right? So, and dump, let us say, let's get the result in console. After that, we can also get it dumped to some target file. Let's say this. It is that easy actually with a prompt engineering within artificial intelligence. Yeah. See, it's over. So we are just asking this AI tool, which is ChatGPT based on large language model, where we just subtract some input file and it is reading it based on comma delimiter and performing group by max for C2 column based on C1 group and printing it. See how easy is this? Now I can just copy and paste it. See, that's a code, right? Now let's say group by, which is a max dot p1. Now we can just run. That's it. See here, we got 118. Same thing, we got it with cloud data integration. See how easy is this? Yeah. Then we can, others also same, 5, 1, 2, 2, 22, right? So 5, 1, 2, 22. Last one, it is ignored in what this artificial intelligence because it is considering only valid data. If you want to consider even empty data, we can modify. So modify above code to consider what empty data to calculate aggregation. Okay. See here, drop post where C1 or C2 are empty or not. So here, let's see. If you don't get it, you can just modify again. So it's very easy actually. So till 22 we got it. So we can modify above code to calculate. For MP. First question. So we can see here, so last one, right? It is just not a number. It's not a number, right? Empty. It's just ignore it. Yeah? So even we calculate, it doesn't make sense at all. Yeah? So this way, we can make ChatGPT or AI tool to perform the appropriate aggregation for a given input data. Yeah? So that's it. Like how one can start performing aggregation in this ChatGPT. Yeah. So that's all, right? Now let us start getting into what we call the next step. Yeah. So which is going to be like how to perform converting unstructured data to the structured data. Yeah. So that's what. So we need to take a look at. Yeah. So remember, performing this structured data manipulation is quite okay. It's not that easy. It's okay, but applying any calculation for the unstructured data, which is going to be the complex part. Yeah. So which means we need to understand like how to perform first thing, converting unstructured data to structured data, and then start applying what you call appropriate aggregation. So that is going to be the second part. Yeah. So unstructured data, we can have PDF document, Word document, data from log file, data from email, data from social media, whatever. So data could come from different medias. So now we need to start understanding like how to take care of conversion. Once it convert, then we can start applying appropriate operation of data integration, right? First, let us try to supply any input data which is in what unstructured form, right? Let us try doing it. For example, let us say we have got a task log, which is going to become input. This is an unstructured form, right? What we need to do here, first we need to understand like how one can convert this particular log file data to structured form. To do that, there's a pre-built intelligent structure model which is going to help us in order to perform the conversion. So again, this ISM, which is intelligent structure model, is based on what? Cloud artificial intelligence. That's why I gave one example for a example, like how easily we could able to perform what you call data integration operations by using what AI tools. ChatGPT is one of the AI tools, right? Here also we can convert unstructured to structured quite easily over here. Yeah. So let us try doing it. Yeah. So to do that, we can just go to new and select a component where we can supply this task log as input to this data integration, which will take the responsibility of converting it to structured data. Yeah. So let us try doing it. So select intelligent structure model and click on create. Yeah. So let's say intelligent structure model based on what? A log file. Yeah. So that's what we are trying to do here, right? So let's say here you can put unstructured to structured conversion. Yeah. So now we can just choose a file. So like example, task log. That's what we just saw it, right? So let's go to that location. Source. Yeah. Then select task log.txt. See here, we just loaded it. Now we can just discover the structure. Yeah. See, now with this, it got generated a model with n number of fields, element, value 1, token, element, value 2, date, time, whatever. Now we can also see that in the relational form. Can you see? 1, 2, 3, 4, 5, which means it is clearly converted unstructured to what structured form. And we can also see even JSON format or XML format. See here, element started here, element ended here. Within that, we can see multiple attributes like a value 1, token, date, time, and value 2. So this is how we could able to see the result here. And then second part, which is going to be second element, which is second record. This is what we can see. Same, it is repeated for all other rows. So this way, one can start converting unstructured data to what structured data. That's it. Now the next question: how one can process this particular data within this data integration? To do that, we have got another transformation which we call the structure parser transformation. Let us see how we could use that. Yeah. I'm just saving it and closed. Yeah. So now let me try to create a new mapping. Okay. Yeah. Here we can use what? Structure parser transformation. Yeah. Now select structure parser. Click on select. We just built one ISM model, right? That we need to select. See, integer structure model, log file, unstructured structure. We give description, right? It is valid anyway. I think it's clear, right? Yeah, we are just selecting it like we did for hierarchy parser, hierarchy builder, right? We selected hierarchical schema component. Similarly, here you are selecting what? Intelligent structure model. Yeah. And click on select. Yeah. Then we can see the output format, which could be relational, JSON, or whatever. Let us start with what? Relational form. Yeah. Yes. Next, task log. We have, right? So, like as I said earlier, if we deal with XML or any data, what we need to do? We need to start supplying the file as input, which will be stored in a string. Example, we can select, we can open the log path, yeah, where we can see what the path and file name here, right? So, so that will be taken as input to structure parser transformation. Yeah. Let us see that. It's just like a indirect file, but it's not an indirect file, but syntax wise it is same. Yeah. Now let us configure this map it structure parser. Now let's configure the source. Yeah. Select connection, which is source file connection. Click on select. Yeah. So log path file, right? Yes. So here, this is the one, right? This is the actual input file. Yeah. Or you can say actual data file. So let's preview the data. Yes, see. So you can see path and file name. And then say done. In that, we can see one field which is log path. Yeah. Okay. Now let us try to map output of the structure parser to a target, where we can take topmost element which is root. So whatever is there under that, all the fields will be transferred to a target. Yeah. So let's configure the structure parser transformation. So this is done already. We separate ISM log file and output is what? Relational. Yeah. So input field there's only one, which is what? Log path, right? Then perform the field mapping where we can connect log path to file path. Yeah. So that's it. Like how one can map log path to what file path, which is input within this structure parser transformation, right? So that's it. Now, if you look at the output fields, see element within that we can see five fields, which is structurally already converted, right, by intelligent structure model. Yeah. Now let's configure target. That's it's very easy actually. Configuration part. We just need to know the flow. That's all. Yeah. Let us try the connection. Yeah, supply the file name, structure to structure, right? Which is structure parser result. Dot txt. So based on what log file? Okay, looks like already file is there. Oh, that's it. Yeah. Now let us apply the mapping name. Mapping underscore structure. Parts are based on the log file. Yeah. And then save it. That's it. Yeah. Then run. Yeah. Okay. Let us try to refresh. See, 7 rows got processed. Let us see whether we got the result in the target, which is what structured data. See, we got right value one, token, second field, third field, fourth, and fifth, which means what unstructured data to delimited data, which is structured form, right? We can clearly see that. For example, this is the value one, enclosed in double quotes, comma separated. Then this is a token. Then this is a date uh, till this. Sorry, till this. Then this is the time. Then followed by value two, which is a simple string here. That's all. Similarly, same thing got repeated for other rows. Yeah. So similarly, if you want the same thing in XML form or JSON form, we just have to specify different output format. Let us see that. So let us say we use another structure parser and then add separate target here, yeah, to deal with what another type of target, which is XML or whatever. Yeah. Now let's configure second structure parser. Yeah. So click on default. So we can give the same thing. Yeah. See here, instead of relational, let's say we supply XML. Fine. Rest everything is same. Only output format we are just changing it. Which means we can also convert source to what? Different formatted results. Yeah. So here it is same as earlier, which is output here. Now let us see the structure parser part, where the input field is same, which is log path, then map it to the structure parser. So log path to file path. See, input is same as earlier, like what we did. Only thing here is output format is different. Yeah. See, this is the output. Earlier we have seen five different fields, but within the output itself, you'll have five separate fields because XML, right? Yeah. It will be stored in a string actually. So we all know that, right? How the format of this XML would look like. Type and length you can change it, but depending upon number of characters. Yeah. Okay. Now let us try to configure the target, which is XML stuff. Yes. So structure parser with XML target. In a sense, we are trying to convert log data to XML. So we can store it in text also, but XML format. Yeah. That's all. Now we can change the name here. Log file with text and XML. Right? Both the formats, right? So this is a text. This is XML, right? Oh, this is here. Yeah. Now let us save it and run. Yeah. Yeah. Run this map. So click on my jobs. Yeah.
Can we also use this intelligent structure to read Excel files also?
Yes, we can use it to read Excel sheet, even normal file or PDF documents, Word documents, any type. Yeah. But for now, it supports this text format. Yes. In future, yes, you are right. It supports all types. Yeah. Correct.
Yeah, got it.
Okay. Yeah. So now all the rows got processed. So we can see XML. We give XML, right? This one. Yes. See, we got it. Output is one top level field name, which is a header. Then, as we all know that any XML would follow DOM architecture, which is document object model, which means topmost element will be document. Then within that, whatever data we have, right, table, then element. Within the element, we got 5 fields. See, so that's it. So value one, token, date and time. Then we can see value two. That's it. Like how we can start looking at the first row. Then we can see the second row over here and third row over here. That's it. This way, we could able to see all the rows. Yeah, like how one can able to generate the result in specified form. That's all. This XML, I think text we have already seen it. Yeah. Similarly, if you want this in JSON, that also we could do it. So similar to XML only, JSON format would look bit easier than XML. That's only one difference. Rest everything is same. Let us see that also. There's a benefit here. So let's say one target for JSON, and then we can see your structure parser. Yeah. So let's map. Okay, first we need to configure structure parser. Yeah. Okay. Yes, can you see JSON here? That's it. Now let us map this and then map output of this to target. Here also you can see output because for XML also we saw same thing, right? Here also it is same. Only the way the data representation is different here. That's all. Yeah, it's easy in JSON compared to XML. That's all. Nothing else. Yeah. Now let's configure structure parser. Incoming is same and field mapping we should do it here. Yeah. Map log path to file path here and then see output fields where we got output field name. That's all. Yeah. Now let us set the target to yeah. Okay. So this is what structure parser to produce what JSON format. We can sort in text also from log, right? JSON from log. Yes, that's it. Yeah. Now we can see here, we can also supply here JSON. Yeah. And then save it. Then run it. Yeah. Click on my jobs. Okay. So let us try to refresh here. Say we got all the rows. Now we can look at this JSON format. See, we got it. So this is the first block, right? And this is second block. So value, token, date, time. See, everything is result is same. The way the representation different. XML, open tag, close tag, all that. Text, line by line with a delimiter. JSON, blocks with a number of fields. That's all, nothing else. Yeah. So likewise, you can see for all the rows. Yeah. Yeah. So which means whatever format that you, whatever means whatever this guy supports, right? The formats. Like I think we have seen only three with a practical example, but it also supports what you call other formats. Like for example, we have seen Avro, which is one more format, Parquet, WordC. So when you talk about this big data, in that case, then we generate Avro format, similar Parquet and ORC. But anyway, they'll add some more target types. For now, they're supporting only this much. Yeah. So that's it. Like how we can convert unstructured to structured to look at the result in the relevant target. Yeah. So that's all we should do it here, right? So now let us start getting into what you call next step, which is going to be what? Like I didn't talk about the sorter algorithm, right? We've only discussed like how one can configure this particular mapping with a sorter, right? But sorter is expensive transformation because it is going to generate or create multiple threads. Not only that, we have to make sure that we have got enough space here. Plus, because that's where temporary operations of sorting would take place. And on top of that, if you want to generate some unique rows, you can just enable the checkbox so that You'll get unique rows, row level distinction, not at column level. Yeah. So let us see that first. Then we'll talk about algorithm. Yeah. Okay, I didn't talk about this, right? Okay. So let us refresh this. There is error here. See, expecting keys to be ascending. Which one? Oh, let's see. This is configured, right? Okay. So this is done. This is ascending only. Then distant rows. Why is this? Let us see. So did I select by any chance here sorted input? I think the year we have not done anything, right? We didn't touch that. Hmm. We're focusing only on this, right? Let us see why we are getting that error. Oh, 6 rows got processed. See, it still got failed. Why? Let us see where. Source itself, 11 rows. Target 1. Count result is fine. Some result has a problem. Now let us see. Where is that? Where is that? Count result is fine. This one is some result. Yes, this has a problem. But here we have used sort, right? Yes, this is fine. Let's say we are not using this. Hmm. And we already pre-sorted here. This is fine. Okay. Let us see the distinct has been taken out. Why distinct is creating problem here? Okay. So let us refresh this. It is successful. Yeah. 8 rows, some result, right? So we got it. There's no problem. Yeah. Now if you look at this particular data, yeah, so it is trying to perform what you call creating unique rows. That's where we got the problem, right? Let us see. So distinct is creating problem. Let's see. Should not come. This is fine. Logically, we don't remove duplicates before we take it as input to the aggregator. No? We directly eliminate duplicates and send it to a target. That's what usually we do it. Yeah. So, see. So once you remove duplicates, where do you have the question of getting it aggregator, right? Because they're gone already. They'll be unique records. Within unique records, performing any aggregation doesn't make any sense at all. No? Yes. So now we got 12 rows. So now let us see. So here we are trying to perform distinct. See, this is only one duplicate row. If you look at here, right? 1, 2, 3, 1, 2, 3. So this is eliminated here, right? So your total count here, sorry, here, if you look at here, 4, 8, 9. And here we can see less, 4, 8 only, because one got eliminated, because there's only one duplicate row here, right? That's all unique rows. Yeah. So this way, we can also eliminate what duplicate records within the sorted transformation. Yeah. So, and I think we discussed about temp directory, right? where we use this particular temp directory to perform intermediate sort operations. Plus, if you want, by default, nulls will be equal priority as not null data. If you want to make it low, we can also do it. Yeah. And cache size similar to aggregator we discussed, right? Which means what? So caching size should be calculated based on what input data. Yeah. If you have more rows, the size will be more. If you are not sure about it, like how to calculate, we can just use auto. Informatica will take care of it by allocating chunk of size. Yeah. But to make it optimal, right, it's better to use value and supply the actual value here. Example, a larger number, depending upon the amount of input data that we have it here. Yeah. If you have only 1024 bytes or kilobytes, we can specify only that number. Yeah. These are all optimal stuffs. Yeah. So every day we need to calculate the size. We need to parameterize this, change the parameter value so that you'll get optimal results. Yeah. People are not worried about this much because nowadays see, resources have become cheap, like CPUs or disk and memory. Right? That's why people are least bothered about this. Yeah. Because we got cloud, right, where we get at a cheaper price to get more resources, right? So pay per use, right? So as and when we need, we just use it and then deallocate those resources. Yeah. Okay. See, we got it. So that's it. We just have to calculate. The result will be same. There won't be any change at all. But yes, the number we need to calculate based on the input data. Yeah. So that's it. Like how we can start getting into this what sorter. So I'll talk about sorter algorithm tomorrow, like how sorter works and how many threads we have, how those threads would talk to each other to perform sorting. After that, we'll start getting into what another transformation, right? So yeah, that's all for today. If you have any questions, Venkat and Sravanti, you can shout out. Ajit, oh, Ajit has some problem. Any questions, Ajit?
I'm fine.
I'm
Okay.
fine too. Thank you.
Okay. So thanks to all of you. So we'll meet tomorrow at the same time, same link. Yeah. Bye. Venkat, you'll get recordings today. And Ajit, yeah. Bye.
Yeah, bye, Master.